Hello, Bagi Bayaw. Today I'm going to show how to solve heat transfer, chapter 9, overview of heat transfer. So this problem is a state conduction through composite wall. So this is the problem. A vertical furnace wall is made up of an inner wall of fabric 20 centimeter and thick, followed by the insulating brick 15 centimeter thick, and an outer wall of steel is 1 centimeter thick. The surface temperature of the wall adjacent to the combustion chamber is 1200 degrees Celsius, while that of the outer surface steel is 50 degrees Celsius. The thermal conductivities of the wall material in watt per meter times Kelvin are fabric is 10, insulating brick is 0.26, and steel is 45. Neglecting the film resistance and contact resistance of joint, determine that the heat loss per square meter of wall are. So we are going to find the heat flux. So this is the figure. We have the red one is fabric, the orange one is insulating brick, and the steel is yellow. So the given is temperature in is 1000 degrees Celsius converted into Kelvin, so 1200 degrees Celsius rather plus 273 is equal to 1473 Kelvin. Then temperature out is equal to 50 degrees Celsius plus 273 is equal to 373 Kelvin. The next is the thickness. Thickness 1 is fabric is 20 centimeter converted into meter. So 20 divided by 100 is equal to 0.2 meter. Same process with the thickness 2 and thickness 3. So 15 centimeter to meter, we have 0.15 meter, and 1 centimeter to meter is 0.01 meter. Then after that, we're going to find their thermal conductivity. The thermal conductivity for the fabric is 10 watt per meter times Kelvin. For our insulating brick is 0.26 watt per meter times Kelvin, and for the steel is 45 watt per meter times Kelvin. Then the requirement is Q over area or heat flux. So the equation that we're going to use is Q sub A is equal to temperature in minus temperature out over overview resistance. The equation for overview resistance is thickness over conductivity. So since we have a three wall, so the equation is thickness 1 minus over thermal conductivity plus thickness 2 over thermal conductivity 2 plus thickness 3 over thermal conductivity 3. So first we're going to solve for overview resistance. Since we have the given, we're going to input it's 0.2 meter over 10 watt per meter times Kelvin plus 0.15 meter over 0.26 watt per meter times Kelvin plus 0.01 meter over 45 watt per meter times Kelvin. Our over resistance is 0.5971 meter squared point Kelvin per watt. Then after that, since we already have the overall resistance, we're going to find the heat loss. So temperature in, which is 1473 minus 323, the temperature out over overview resistance 0.5971 meter squared times Kelvin per watt. We're going to cancel the unit Kelvin. Then our heat flux or heat loss is 1925.98 watt per meter squared. Thank you for listening and have a great day, everyone.